Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for solving the best time to buy and sell stock problem. Let's look at the problem description. We are given an integer array of prices where each prices of I is the price of a given stock on the ith day, and we can decide whether to buy or sell the stock, and we can buy it and sell it on the same day, and also we can hold only at most one share of the stock at any time. Find and return the maximum profit we can achieve. This problem is a variant of the previous best time to buy and sell stock, where we hold the stock and decide to sell in the future. In this case, we can decide to sell the stock on the same day to avoid the loss. Then find and return the maximum profit you can achieve. Let's take a look at the example 1. In this, the input price is 715364. In this case, we can buy the stock on the first day, and if we sell it on the second day, we will lose money. So we decide to sell it on the same day so that we avoid the loss, and then we buy the stock the next day and we check the price with the following day. We can make a profit, so we accumulate that profit, and we buy the stock on the same day, and we check the price the following day, which is less than the current price. So we will be losing money here, so we sell it on the same day. Again, the next day we buy it and hold it. We can make a profit if we hold it until the next following day, so we hold it here. So here 3, here 4 plus 3 7. So basically we check the next day price, which we compare the current price with the next day price, and if we can make a profit, we can hold it. If there is a loss, then we can sell it on the same day, and finally we can return the maximum profit that we can achieve. Let's look at the approach to solve this problem. So we are given the prices array, and the expected output is 7. So basically we traverse the prices array, and then in each iteration we compare the current price with the previous day price, and if there is a profit, we hold, otherwise we sell it on the same day. So for example, so traverse the array from starting from index 1 in the price array, and then each iteration we compare the current price with the previous day price to determine whether, if we hold the stock which was bought yesterday, we can make a profit. So if we compare the difference, and by subtracting the previous day price from the current day price, it is going to be -6 here. So like whenever we see a profit, then we add that to the total profit. Otherwise we keep moving forward as if that's a price, the stock purchased on the previous day was sold on the same day. Let's look at the flow chart. Input for this procedure is the prices array, and first we initialize the total profit and the index and the count variable. Index variable is initialized to 1, and the total profit is initialized to 0, and the count is the number of elements in the prices array. So first we check whether we processed all the elements. If so, we return the total profit. Otherwise, we compute the current profit by subtracting the previous day price from the current price, and if that is greater than 0, that means we can make a profit if we hold the stock until tomorrow. So we add that total profit. Otherwise, we move on to the next iteration. So we repeat this until all the elements are processed, and then finally we return the total profit. Let's move on to coding. First I initialize the total profit to 0, and then the count to the number of elements in the input array. This for loop traverses the input array from index 1 to the total number of elements in that array. In each iteration, it computes the current profit between the current day price and the previous day price. If there is a profit, then we add that to the total profit. Otherwise, we move on to the next iteration. And finally, I return the total profit. Next, I'm going to run the test cases. Okay, all the tests passed. Next, I'm going to submit this program. Cool, it's accepted. Next, I'm going to do the code walkthrough with sample input. So we are given an input array, prices 7, 1, 5, 3, 6, 4, and the expected output is 7. So first we initialize the total profit to 0 and the count variable to the number of elements in an array. In this case, it's a 6. And then we initialize the index to 1 so that we start processing from the element at index 1. So on each iteration, we compare this current price with the previous day price to determine whether we can make profit by, if there is a profit, we add it to the total profit. Otherwise, we move on to the next iteration. So on the 0th iteration, first the previous day price is 7, and then the current profit is 0 and the total profit is 0. So when we compare these two prices, so it's 1 minus 7 minus 6, so which is a loss. So we skip this trade. We skip this and move on to the next iteration. And here we subtract the previous day price from the current day price, which is the profit is 4. So we add the current profit to the total profit. So when we leave this iteration, so the total profit becomes 4. On iteration 2, the previous day price is 5 and the current day price is 3. In this trade, we will lose money. So we move on to the next iteration. So when we leave, so in this, we make a profit of minus 2. So we skip this and the total profit remain 4. On the iteration 3, the current day price is day price is 6 and the previous day price is 3. In this trade, we'll make a profit of 3. So that's why the current profit is 3. So we add that current profit to the total profit. So we get 7. On the last iteration, the current price is 4 and the previous day price is 6. In this case, we lose 2, minus 2. So the current profit is minus 2. So we skip this. So the total profit at the end is 7. So that is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. First, we see how many times this loop runs for this input. So this has 6 elements. So starting from index 1 all the way to the total number of elements. So it runs 5 times. So for an input size of n, this loop will run n minus 1 times. So the time complexity for this solution is order of n. And with respect to the space complexity, it is order of 1 because we are not allocating any additional space in terms of the size of the input. So all we do is we have just 2 variables here. So space complexity for this solution is order of 1. Thanks for watching this video. Have a great day.